Have you ever dreamed of journeying to distant stars, not in centuries, but in mere moments? The concept of a warp drive, a way to travel faster than light without violating physics, captures our imagination, but it comes with a mind-bending requirement. The simple answer is that negative energy is crucial for a theoretical warp drive to work, because it provides the exotic matter needed to bend spacetime in a very specific way. Without this unique form of energy, creating a stable and functional warp bubble, which allows for faster-than-light travel, remains an impossible dream according to our current understanding of physics. The core mechanism behind a warp drive involves creating a warp bubble around a spaceship. Inside this bubble, the ship itself remains stationary relative to its immediate surroundings. However, the spacetime fabric asterisk outside the bubble is compressed in front of it and expanded behind it. This clever manipulation of spacetime effectively moves the destination closer and then pushes the bubble along, allowing the ship to cover vast distances faster than light could travel through normal space. The immense energy required to achieve this extreme bending of spacetime is where negative energy comes in. Imagine trying to push a dense bowling ball through a stretched rubber sheet. It creates a dip. Now imagine creating an asterisk opposite asterisk effect, a sort of anti-gravity force that pulls the sheet up. That is what negative energy would do to spacetime. It provides the repulsive gravitational effect necessary to create the distorted spacetime geometry of the warp bubble. This means that instead of just mass pulling spacetime inward, this exotic energy pushes it outward, allowing for the required contraction and expansion. While negative energy sounds like science fiction, it does have a theoretical basis in quantum mechanics. For instance, the Casimir effect, observed in laboratories, demonstrates how quantum fluctuations between two closely placed parallel plates can create a region with what amounts to a small amount of negative energy density. However, the amount of negative energy needed for a practical warp drive is astronomical, vastly exceeding anything we can currently produce or even measure. It would require densities of negative energy for beyond anything remotely plausible, perhaps even equivalent to the energy contained within a star. So, while the idea of negative energy for a warp drive is a profound theoretical hurdle, understanding its role helps us grasp the extreme demands of faster-than-light travel. It is not just about raw power. It is about finding a way to manipulate the very fabric of reality in a way that currently remains in the realm of deep theoretical physics, constantly pushing the boundaries of our scientific imagination towards a truly star-spanning future.